Vanakkam, Namaste, Namaskar. Back to Jal Prayag. I'm going to continue on the topic of this basic of Earth, which is actually leading us to more on practical navigation and which will end up on day's work. So let me go on part two of the same, and we'll again do a small presentation on the continuation right now. So I call it part two, Earth's basics. Before I start off, I'm going to quickly do a small recap of what we did yesterday. So if you see, we had done Earth's shape. Then we talked about major and minor axis. Then we even saw the axis of Earth's rotation, which is actually the minor one. That leads to the poles. Then we saw the direction of Earth's rotation, which was easterly. And at the end, we discussed about the tilt of Earth's axis. This is what we did. So we'll continue on the same basics. Let us deal with a few new concepts or definitions also. The first one I'm going to talk about is a great circle, which I call it GC. So we'll be always calling it GC. Let us look at what is great circle. It is basically a circle drawn on the Earth's surface. That means I'm going to show you with a example a piece of orange also. So I can take any spear or orange or a ball, and I can draw a circle on it on the surface. But the catch is the plane of this circle, which I'm going to draw, has to pass through the center of the Earth. That is what is the criteria. So when I satisfy this criteria of plane passing through the center of the Earth, you will be dividing the Earth into two halves and they will be equal. Okay, and the best way for me to show you is using a piece of orange. So let us say I give you a piece of orange. I take a marker on it and draw a circle on it. Okay, I draw a circle. Then I'm going to take a knife and I'm going to cut through exactly on that circle which I had drawn. But the catch is my knife should pass through the center, okay, center of this orange. So when I do it, you will see I'll cut exactly into two equal halves. Then where is the great circle here? The great circle is a circle drawn on the surface of the Earth. So that means the black marker which I had drawn, I'm just depicting it on the half piece of the orange, because that is a circle whose plane has passed through the center. So when I use this concept, it is called a great circle. It has got some importance. I'll just later on give you in a summary. Let us finish off something else also, and then we'll talk about it. Okay. So what are the properties of a great circle? Okay, this is again one more picture showing you different great circles. You can see no matter which direction you cut that orange, as far as the knife passes through the center, please remember that circle drawn on the surface of that particular earth or the orange or whatever you want to call it is called a great circle. You can see three examples of great circle. So let us look at some properties. There are some properties which we need to know. Whatever concept I'm talking about leads to sailing. Basically, that is what is practical navigation and sailing. So when I do sailing, I need a start point and an end point. So I'm going to take two waypoints. So I call it waypoints. If these two waypoints are diametrically opposite of the sphere, okay, I'm giving you a few more examples. If these two waypoints are diametrically opposite on the sphere, please remember there's a property that I can draw infinite number of great circles passing through these points, infinite numbers. Okay. So I'm just trying to depict it here. See, I'm taking alpha and bravo. The red line, what I've drawn, is also a great circle. Why? Because you will see that it is passing through the center of that particular sphere. So this is a great circle. And since this is a two-dimensional picture, I need to show you partly as three dimensions. So I'm going to curve the remaining kind of great circles, which is as good as if you turn that ball or the orange towards you, every time you turn, the green line which I've just drawn right now will become a straight line because it faces you. Okay, you'll have to imagine a little bit. So you can see this purple one which I've drawn, that also, if I turn that ball towards me, that purple line also will become straight when it matches exactly in line with my eyes. So since I'm drawing it in a two-dimensional picture, I have to show you a curved line. It is basically that circle drawn on the surface of the Earth. So this is what I've shown you. I've shown you two waypoints, which is alpha and bravo, which are diametrically opposite on the sphere. Then I can draw infinite number of great circles between these 2 points. That means it has to pass through these points. Now, there's a second property. If these 2 points, alpha and bravo, are not diametrically opposite on the surface of the Earth, then let us say I'm going to give you two waypoints, alpha and bravo. You see, they are not diametrically opposite. Then the property of the Earth or the sphere is I can draw only one GC passing through these two waypoints. Okay, this is important, the property of GC. Now, once we are done with GC, let us go to a small circle. Then what do you mean by a small circle? Again, small circle is also a circle drawn on the surface of the Earth. But this time, if I take the knife and pass it through that circle, please remember that knife is not going to pass through the center of the Earth, which means that I'll still have two pieces of that orange, but they will be unequal. Okay, I'm going to show you a picture. See here. So you can imagine I had drawn and I had used a knife to cut it, but the pieces were not equal. So these are small circles. This is what is a small circle. One single picture shows you a good idea about a small circle and great circle in this one single picture. You can see as far as the knife passes through the center, I call it GC. If the knife does not pass through the center, I call it small circle. Okay. Now, again, a few pictures to depict. You can see the plane. Okay, instead of knife, this is the plane which I was talking about. When I draw a circle, the plane of that circle should pass through the center. Now you can see is shown with a rectangle, and that is a plane actually. It is as if I'm putting a thin rectangular metal sheet and I can chop that earth off. So you can imagine that. A quick summary. Please remember, the great circle is the largest circle that can be drawn on a sphere. That is the largest circle. And they always bisect the earth into two equal halves. What is so important about it? It has got importance of navigation, whereby I can find out the shortest distance route if I draw a great circle. We'll be talking about great circle routes and different other routes a little bit later in the part of navigation. But right now, this is what we need to know. And a small circle is any other circle. That's it. You as far as the plane does not pass through the center, it's a small circle. Let us go to the next important definition, which is your equator. What is an equator? Please remember, equator is a great circle. Okay, so the moment I say great circle, you know the plane has to pass through the center of the Earth. But this plane, even though it passes through the center of the Earth, it is perpendicular to the axis of the Earth. So I'm going to show you that. We know that this is the axis of the Earth, which is the minor axis. And I need to draw one more GC, and the plane of the GC should pass through the center and should be perpendicular. Now, this is the answer for you. So this is one more plane or one more GC which passes through the center, but it is 90 degree to the axis. Okay. So your equator divides Earth into two hemispheres or two halves. One is northern hemisphere and southern hemisphere. And latitudes, that is the first kind of position fixing tool, which we are going to see later on. The latitudes are measured always from the equator. So your equator becomes the zero for latitude measurements. So you normally go from 0 to 90 up to the poles, which is north, and then 0 to 90 on the south. So it's a very important zero reference point for one of our position fixing tools. Okay. Now let us look into something else, because equator is not the only one. I need more graduations on the Earth for reading. So I call them parallels of latitude. So let us see what is parallel of latitude. Remember, equator was a GC. And what is parallel of latitude? They are small circles on the Earth's surface. But the catch is the plane of this small circle has to be parallel to the plane of equator. The moment I say parallel to the plane of equator, they'll be obviously running east and west, and all of them will be perpendicular to the axis. So I'm going to show you that. So this is your equator, this is your axis, and these are all parallels of latitude, and they're all small circles. All of them are perpendicular to the axis. So this is what is your parallels of latitude. Okay. Now let us go to the next position fixing tool, which is very important for you to look on the chart of the Earth, which is called meridian. So let us look at a meridian. Please remember, equator and parallel of latitudes, they are lines, they run east-west. So let us look at a meridian. Please remember, meridian is a half of a great circle. It is half of a great circle drawn on the Earth's surface, joining both the poles. Please remember, both the poles are diametrically opposite. So you will realize that you will come to that concept of infinite number of GCs. So let me just show you. Okay. This is your North Pole and South Pole. And you please see, these are all meridians. These are all meridians. Okay. All of them are meridians. Please remember, the other half of this meridian is on the other side of the Earth, and they also form one more meridian. So for me, meridian is only half of a GC. Okay, it's half of a GC. Now this we already know is the equator, and this we already know is parallel of latitudes. Since meridians run north and south, please remember they will intersect the equator and all the parallel of latitudes at 90 degrees. So wherever you go, this picture looks curved. Why? Because I'm trying to use a two-dimensional picture. You can imagine as if you want to see different these curves. You can just turn it and keep it right in front of your eyes. You will see it looks like a straight line. Okay. Now this is also one more meridian, so it'll be straight. Now you can keep turning it, and each color can become straight for you as far as your eyes are matching it. Okay. Your recap, all your meridians are GCs, basically half of GCs. Now let us look at something important here. Then what is a prime meridian? Okay, prime meridian is the reference point. So that reference point has been chosen, the one which is passing through Greenwich in UK. So that is what is called your zero reference for your longitude measurements. So meridians are basically longitudes. So it is a zero reference for your longitudes, and they are represented by 3 digits of zeros, because the measurements can start from 0 to 180 degrees. I'm just going to show you. And if you see, I marked the equator as 00 degrees because they can go from 00 to 90. Okay. It's always better to have that zero always added so that you're not missing the digits of your positions. So it is always prudent to mark it at zero. Even if it is not there, you should mark it as zero. Now, since I know what is prime, which is zero reference, then that means I can measure the other meridians also. So usually what they do, we split the meridians into two halves again, just like what we did in the equator, 0 to 90 north and 0 to 90 south. Now I'm going to do is 0 to 180 degree east. It will go in this direction, and 0 to 180 degree west, which will go in this direction. So my measurements are always from 0 to 180. This is the end of this module. As I said, it's going to be a small module, and it's going to continue like this. I'll keep making short videos, and it's going to take quite some time for us to complete the whole series of these concepts. So please keep watching Jal Prayag. Until then, Vanakkam, Namaste, Namaskar, till I catch you with the next one.